Have you ever wondered why applications crash hopelessly, especially in production? In this video, we are breaking down the top 5 reasons why apps crash most often in production and how to avoid them. First on my list is the null pointer exception. A null pointer exception occurs when a program tries to access or invoke a method on an object that has not been initialized. For instance, when an object value is null. Null pointer exception is a common runtime error in languages like Java, and it indicates that the code attempted to use an object reference before it was assigned a valid memory address. The second possible causes of apps crashing in production is out-of-memory error. An out-of-memory error occurs when the Java virtual machine, also known as JVM, runs out of memory and cannot allocate additional memory to continue execution. It typically indicates that the heap space is exhausted and the garbage collector cannot free up enough memory to satisfy a new memory request. The third reason that can cause an app to crash hopelessly in production can be as a result of unhandled exceptions. Unhandled exceptions in areas such as network, databases, or input and output operations can crash a program if not properly handled. It can also make the application to behave unpredictably and leave resources open if not managed using try-catch blocks or proper error handling mechanisms. The fourth reason for apps crashing in production can be as a result of deadlocks. Now, what is a deadlock? A deadlock occurs when 2 or more threads are blocked forever, each waiting for the other to release a resource they need to proceed. It typically arises in multi-threaded programs due to improper handling of shared resources like locks, which will definitely lead to a complete standstill during process execution. The fifth reason on my list for apps crashing in production is as a result of Stack Overflow error. Now, this will be our main focus in this discussion. A Stack Overflow error occurs when a program's core stack exceeds its maximum limit. This mainly happens because of uncontrolled recursion or secular dependencies, which will then lead to infinite nesting of function calls until the stack runs out of space. What are the causes of Stack Overflow error? Now, let's look at some of the major causes of Stack Overflow error. Number 1 is unbounded recursion. Unbounded recursion is a situation where a function calls itself infinitely. Number 2 is deep recursion. Deep recursion is a situation where there are too many nested calls. Number 3 is secular dependencies. Secular dependency occurs when 2 or more functions or objects are referencing each other indefinitely. Number 4 is large stack allocations. Declaring large variables like big arrays inside functions can consume stack space quickly. Ways to resolve Stack Overflow error. Let's look at some of the ways to resolve a Stack Overflow error. Number 1 is by avoiding large stack allocations. I would prefer you use heap memory instead. Number 2 is by replacing recursion with iteration. So use for loops and while loops in order to avoid adding stacked frames. Number 3 is by avoiding deep nesting by all means. Alright? Number 4, by breaking secular dependencies. Now, there are several ways to break secular dependencies. Let's quickly look at some of the ways to break secular dependencies. Number 1 is through the use of *JSON-ignore. You can use *JSON-ignore on the object where you think secular dependency might occur. Number 2 is through the use of *JSON back reference and *JSON managed reference. Number 3 is through the use of DTOs. Now, the most efficient approach for managing and breaking secular dependencies is through the use of DTOs. DTOs help in decoupling entities from API responses. They also help in eliminating secular references without losing data. They also help in improving performance by serializing only needed fields. Now, here are some of the possible impact of unhandled Stack Overflow error. Let's look at some of the real-world impact of a Stack Overflow error if not properly caught or handled. Number 1, unhandled Stack Overflow error can lead to the premature termination of programs. Number 2, it can cause poor user experience as API endpoint can suddenly fail with a 500 internal server error. It is usually very difficult to debug. It can also cause performance degradation in the system as it can lead to excessive memory usage before crashing the system. It can also cause loss of data, especially if the app was processing data at the time of the exception. Unsaved data may be lost and never recovered. Now, here are some of the reasons why I think you should have a good knowledge of the top 5 major causes of apps crashing in production as a software engineer. Number 1, it will teach you how to build stable applications that won't crash unnecessarily. Number 2, understanding how and why these errors occur improves your debugging and problem-solving skills. Number 3, it will teach you how to write efficient, clean and scalable code, especially when dealing with recursive algorithms. Number 4, it will teach you how to build applications that guarantees professional readiness in real-world development, especially in system programming or backend development, because stack issues can have serious consequences if not properly handled. Stack Overflow and recursion problem is a very hot topic in technical interviews and coding tests. Now, you can liken a Stack Overflow error to a tower of books falling over because you keep adding more books on top without ever taking anyone off. Each function call is like adding a book to the stack. Book in this scenario is represented by a function call. So now, if you keep adding book, you keep stacking book continuously, eventually the book will form a tower and the tower will become unstable and it will collapse. This is exactly how Stack Overflow error also causes a program to crash when you keep calling a function recursively. In summary, all the errors mentioned above are all symptoms of flawed logic or poor coding practices. As developers, it is our responsibilities to write clean, efficient, and robust code that can withstand real-world usage. Follow for more.